Our next presenter, Gregor, he's the head of data architecture at UBS, and he will give us a perspective on data-centric journey within the financial industry for building a connected data catalog with a knowledge graph. So please welcome Gregor and give us a deeper introduction and more on your experiences.
Hi, everyone. Steve, thanks for the introduction. My name is Gregor Wobbe. I work for UBS. For those of you who don't know UBS, we're one of the largest wealth management companies, roughly 70,000 employees worldwide, and primarily focused on asset management, wealth management, and investment banking. Let me start sharing my screen. Today, I would like to show you what our journey on becoming a more data-centric organization looks like. So I would dive right in. Our current situation, we have something called applications. And you see those little walled gardens? This is just and to give you an idea. So we have roughly 5,000 of those walled gardens, and each of it is what we call a business application. And collectively, those 5,000 applications are used to run the bank. Each of those applications, or aka walled gardens, comes with their own data store. And you see that depicted here. It's if you want to get data from an application, you have to talk to the application owner. And you need to know exactly what type of data you want and for what purpose. And where this becomes a challenge is when it comes to the integration. Between two applications, that's relatively easy. But as it grows to 10, 50 applications, it becomes more and more challenging. And our application owners are incredibly inventive in integrating and moving data from one application to the next. But you can imagine, once you get to a level of 500, it becomes a hard problem. Not just a challenge. Our scale was 5,000, and that's the reason where we sat down and said, for our next generation data platform, can we do things a little different? Right, so the data movement within the firm or within the applications is our main challenge, and it prevents us from making changes fast and agile. It's incredibly expensive to introduce new changes or change one piece of the puzzle, and knowing what are the other applications that are impacted by a change, especially when there's a lot of interconnectivity between those applications. The biggest problem is, and this is when you try to pull data together to make informed decisions. And for the longest time, we tried to build this central data store. And it started with data warehouses. And you see all those little people trying to pull data from underneath, from the operational systems, from applications into the central data store. Started out with, and that goes back decades, started out with mainframe, data warehouse, data vaults. Every time we jumped on a new technology, we were faced with the same problem. Those little people, those heroic attempts to pull data out and organize it in a central data store. So far, our experience is that it never really works. It works in pockets. So we have successful data warehouses. We have successful data lakes in pockets. But as soon as we get to a point where we want to have an overview of the entire ecosystem, the plan falls apart because it's just too much work on the central data team to pull all this data together from 5,000 applications. So that was the driver to say, can we do things a little different, and what do we actually want? What does good look like? And that's our goal. We want to have this data layer that is easy to understand. And what we mean with easy to understand is that a motivated person should be able to understand the data layer within an afternoon or two, to go through and understand where is my data, what are all the entities that I need to pull together. And the reason why we want to have this easy to understand data layer is because we want to enable our machine learning and AI teams to work with the data and generate insights for our clients. That is the main driver. So we see AI as a fundamental piece of technology that we will leverage to help making our clients, or help our clients making better decisions. And to do that, we need to have a well-curated data layer. So right now we spend a lot of time cleaning and massaging the data, and less on the insight part. And we want to move that. We want to move the equation towards spending way more time on working or generating insights rather than on the data engineering aspect. So for that, well, that's a goal. How do we get there? And that's is basically 4 simple steps. The first step, and that's falls under the connected data catalog topic. There are 4 steps. So the first step is to catalog all our enterprise assets. And what it means is knowing exactly, for example, where are all the relational tables, where are all the files. Those are all data assets for us. What do they mean? And can I trust the data? So it's basically find the data, understand the data, then trust the data, and finally use it. So the first step there is, the first bullet point is cataloging all of it. Second step is building a conceptual layer, and that's this box on the top. It's your schema. That is basically the machine-readable version of a data model. Then the third step would be to map all the data assets to the conceptual layer. And there's no shortage on brilliant and inventive ideas of leveraging machine learning to do that, leveraging people by federating out this work into the teams. And it's a wide spectrum. It's probably the most interesting piece of that puzzle is how do we map between the data assets and the conceptual layer. And then finally is creating a data access layer. That's a box in the middle that we call linked data, and I get to this in a second, is how do we use, or how do we expose all of this to our employees that they can browse through the data and access it and use it. So those are the 4 relatively simple steps, or simple to say, but very hard to implement. And the remaining of this talk will basically, how do we go about implementing those 4 steps? The solution here are leveraging 2 very powerful ideas. One is the idea of a graph, and the other is to do this in a decentralized fashion. We call this a data mesh. It became a bit of a buzzword lately. The main focus here is the decentralized aspect. We realized we cannot be successful by building the one system to rule them all. So those are the 2 ideas. And the graph, I'm a bit of preaching to the choir here. The graph is for us a way to describe any data structure. That's the reason why we use a graph. So we pull data, metadata, it's only about metadata in this case, we pull metadata from all kinds of data structures, be it a table, a tree, unstructured text, images, you name it. And the one example that inspired us to do this is something that's wildly successful on the internet. If you book a flight today, magic happens. If you go on Expedia or Kayak or even just Google and type in a flight from, I don't know what, New York to London, magic happens. And the magic is that 400 airlines expose their flight information in a common format. And that common format is based on something called schema.org. And what you see in the middle here on the slide is a graph representation. But what we really did inside, we used the same functionality that schema.org uses, something called JSON-LD. And we translated all our schema information, all our data models into this schema at UBS. That is based on the same idea, the same technology as schema.org. And the same idea that makes it possible, for example, for Google to display flight information. So that's the foundation. That's the graph aspect of it. And by the way, if you have any questions, I'd like to keep this interactive. Feel free to interrupt me.
There was one in the chat, basically with catalog all, many sources copy and enrich other data. Having all would create a fair amount of redundant data. And kind of with that, how long would that take to catalog all?
I'm not sure if I understand the question. Say it again.
In reference to catalog all, having a catalog of all would create a fair amount of redundant data. And Shane, I'm not sure if there's more to add to that, but that's what I'm reading from the chat.
So we as a first step, that's why I'm a bit confused what the redundancy means. That our first step is to basically get a clear line of sight. What are all the physical assets that we have? If there are redundancies, just knowing about it is for us a small win. We definitely want to know if we have redundant data and then we try to eliminate it. I hope that answered the question.
Yep.
Very
good.
All right, so that's the one foundational idea is the graph. The other idea that we leverage is the decentralized aspect. And for that, we built something we call a data service. It's basically a piece of software. It's a container, and what that container does, it gobbles up data and turns it into a graph representation. That's a data service, the main building block. And we liken it to a cell in the body. And based on the purpose that we assign the cell, the data service can play different roles. But it's our smallest unit that we apply. And many data services together allow now a decentralized mesh. So in this case, you see those products and sales and clients. Each of those are data services, and they expose their data. Now, conceptually, that's relatively easy to depict. But I get to this in a moment. The challenges that we had to implement this in the real world in our organization.
There was another question here. If you're able to share anything, is your internal schema based on any set of upper ontologies or other abstract model?
Yes. So we always start out with an open standard. I list a few in a few minutes, you see some of them listed. And that's always our starting point. So we take, for example, DCAT as our cataloging foundation. We take Provo, all those top-level ontologies, our starting point. But then we call it UBSifying it, because there are certain aspects that are very specific to our firm that are then added to it. But our starting point are always open standards. It's actually a selling point for us. It's so much easier to push this into the organization by pointing to an open standard. Once you say, hey, this is what's used all over the internet, this is our starting point, it's much easier to convince people that it's actually a good idea. If something works for over half of the internet, it certainly works for our organization.
Are you utilizing either FIBO or GIST or any other sort of upper ontology?
We're using FIBO as an inspiration. Again, as a starting point, we have internally very elaborate ontologies, but FIBO is certainly in pieces or in subsets used for us as a foundation. It's to just echo the presenter in the previous talk. What we cannot do is just copy all of FIBO and just drop it. So we take inspiration from FIBO and reference to it, but not in its entirety. It would be overwhelming. And there's a lot of things in FIBO these days that are simply not applicable to us.
Mm-hmm. There's two more in there. Do you want to take them, or do you want to move forward a little bit?
Sure. Yes, please.
Yep. So there was an original question about sort of internally calling it JSON LD instead of just sort of calling it RDF. Is there a business advantage there, or any particular reason you've gone with that terminology?
It is, so JSON LD and RDF are different. So this is really JSON, and the sales, or it's nothing to, there's no sales aspect to it, but the reason why we went the JSON LD route is, now, if you wait for a few more slides, a few minutes, I'll show you this, why we're doing this and why we're using JSON LD. It's not only a graph that we're using, so we're leveraging Kafka. But I'll get to this in a few minutes.
Okay. And one more, have you implemented any kind of conformance validation, for example, Shackle, to balance an open world with the sometimes need for a closed world within the organization?
Yes, we're leveraging Shackle extensively for validation. Yeah.
Okay. Let you keep on here and I'll keep an eye.
Sounds good. So that's conceptually the idea behind those decentralized data services. Now the challenge is, for example, if you look on the right-hand side, clients. It's so easy to say, well, let's just have one data service with clients. In our firm, the reality is there are different definitions, different groups, different lines of business have a different perspective on what a client is for them. So where we always have the challenge that there are multiple data services exposing the same data, but with slight nuances. As much as we want to have just one view of a client, reality is that we have multiple services exposing the same entity, the same client. So that's our major challenge, to deal with the ambiguity and different perspectives on the same entity. Now to the question why we're using JSON LD. This is just one example. So we always have a source, and then we have a data service. And that data service is connecting to the source. In most cases, we're dealing with relational databases or file structures. But those data services, they can connect to a variety of sources. They pull data out, and then what worked incredibly well for us is they exposing the data as JSON LD. And they're leveraging Kafka for this. So all of those data services are piping the data into Kafka topics. And the beauty of this is that at the receiving end, the target, it doesn't have to be a graph. It can be a graph, and we use graphs as a sink. But there are quite a lot of applications who are subscribing to the same message, but they just want to read JSON and then use the data for other purposes, but it's not a graph. And the main reason why this became so successful is because we doubled down on JSON. In the beginning, we exposed RDF, and we had challenges, to say at least, to with the adoption. Now that we switched it to JSON, our adoption rate went through the roof, and developers love it. And as a next step, what we want to use that also to expose GraphQL. But that's just from a technical implementation. It just turned out to win over the developers, we had to go down the JSON route, and it proved quite successful. So that's conceptually what happens. So we use data service to read data from a source and pipe it through Kafka to whatever the targets can subscribe to the Kafka topic. Now, in a larger context, this is what happens with layers. So you see here, those are the green boxes. Those are the applications. And if you think back to the first slide, each of those green fields is basically a walled garden today. And those blue dots, those are the instances of an application. Think of it almost like the different environments. Could be development, test, UAT, production. It could also be, and we leave it to the application owner to decide that, could also be different regions. So you can have a production, the same application could be in Japan and it could be in Switzerland. So those are the blue dots and the green fields. Those are applications. And the information or the metadata comes from an application registry. That's the box on the upper left-hand side. So a data service connects to the application registry and pipes this data into via Kafka. And in this case, we pipe all of this into a graph. Now, a given application environment, let's say production, has infrastructure or leverages infrastructure. So those are your servers and attached storage, network connection, and the information about infrastructure comes from many different systems. I just depicted here one. It's a configuration management database. So what is the hardware? What is the software installed on the hardware? What is the database connection? What's the configuration of the ports and all of this comes from many different metadata systems that provide this information, the whole layer of infrastructure. Some of the infrastructure now contains databases. This is where it gets interesting. Those databases, or the data layer, comes in two flavors. One is the data at rest, and one is data in motion. The data at rest, those are your databases or files sitting on the system. Data in motion, this is when you move data from A to B. And could be via Kafka, via ETL jobs, those are the red lines in between.
So the database itself, the data at rest and the data in motion, needs to be understood and described. And for that, we have a new layer. That's a schema that I referred to before. So the schema at UBS, similar to schema.org, is the one that describes content of our data assets. And finally, just to bring it to all the way to the top of the house, is the business glossary. So the schema maps to a business glossary, and this helps us to understand what actually a given entity or an attribute means and what category it's in. All of this information comes from various sources. And since it's all in Kafka and described via JSON LD, now you can connect all the information through the layers. So if you connect the graph database to all those Kafka pipes, you get the complete picture. This is basically what we're building. In terms of capabilities, so the 4 pillars that we're addressing is want to find all our data assets, finding it, understanding it. Once you find and understand a given data asset, you want to make sure you trust it. And once you trust the data, you also want to make sure that you're allowed to use it. And you see the top level ontologies that we're using as a starting point. They're coming all out of the W3C and are basically our starting points to tackle the data catalog and providing those capabilities.
Had a question in the chat. If your business glossaries are taxonomies or are they simple glossaries, and if you're utilizing Calibra?
I can yes to all to all 3 questions. We're not using only Calibra. We're using, and that was one of the realizations that our journey towards a connected data catalog is basically a data integration challenge. We're using Calibra and we're using Microsoft and we're using homegrown data catalogs, Purview, and. Almost every business unit has their own data cataloging solution. For the business glossary, we have only one, and that's based on taxonomies.
Good. And if you thought about using data usage vocabulary or DOV in addition to DCAT and DQV for the data catalog?
We're using ODRL, or we intend to use ODRL. That's our idea of how do we express licensing, access management information. But we're not there yet. That's in the pipeline, something that we will invest this year.
Cool. And one more, can you speak to the initial resistance from stakeholders or process owners on moving forward? Maybe the turnaround time it took to start from bringing it up, pros and cons on rationale or justification, or what finally convinced people to move forward?
Excellent point. Bring me also to the next slide for lessons learned. Lessons learned. Initial resistance, I guess, is it's like with all new ideas, there is an initial resistance to change at all. We had the benefit that within our firm, there was no one really happy with the experience of the data search experience to begin with. And the realization that we need to change something. And so I have this here as a bullet point number 4, creating small wins. That was our way to get a foot in the door, is to create, we call them small wins. Once you assemble some of those data sources, and then you can create a value slice for the organization, people are getting on board. That was, I guess, the secret sauce to create incremental value and return it back to the organization. And to give an example of one of those value slices was the realization of, once we had cataloged all the technical metadata about our data assets, was the realization of archive tables. That we have a lot of our spend on disk space was used for dormant data that was basically just archived within a database. That's a small win, where you just go back, hey, we can save some money by reducing our data footprint. And there are many more examples like this. So over time, it takes a long time. But creating those small wins was proved very successful for us. The other, and then back to the lessons learned, is this focus on the business domain. So we tend to, as technologists, we tend to fall back into technical discussions and the latest developments of whatever the technology. These days is ChatGPT. The risk there is you leave the business domains behind. And if you don't create those value slices for the business owners, there is a high likelihood of failure. So we're focusing very much on working with our business partners to make sure we're creating value for them and not just playing around with the latest and coolest technology. The other lesson learned, and I mentioned that before, leveraging open standard is almost like a hidden superpower. It's really hard to argue with the W3C standard. And that also helps us convincing people who say, why don't you just buy product XYZ? Because product XYZ may or may not use an open standard. That's especially true for data catalogs. That includes data catalogs that are open source. They rarely follow open standards. Just in the interest of time and for completeness, the third item, that was really a big lesson learned. Thinking about team topologies, not so much in the beginning, but maybe a year into the journey, we realized that our team structure has to change. And there is something called Conway's Law that basically says the organizational structure determines the architecture. And we were lucky to grow in parallel to an organizational change within our organization towards a more agile organization. So we're now structured into pods and tribes, and this structure really benefited our architecture. And we realized early on that we also have to adjust our teams and the purpose of those teams towards the architecture that we have in mind. Very federated architecture that switches to a mindset to treat data as a product. So I highly recommend, if you haven't heard of it, there's a very good book about team topologies to factor this into your own journey if you ever have in a similar situation where you have to build out something that is highly federated. And then last but not least, stay the course. It goes without saying, this is a major undertaking, and convincing people to move to a more data-centric world, data-centric organization, has a lot of challenges and people second-guessing if this is the right course, if it's even worse, the effort. So I encourage you to stay the course. Which brings me to the end of my presentation. Open up for questions. Yes.
We had 2 chat questions. How do you go about getting teams on board that produce mostly data but are not interested in consuming them? They don't have the incentive to move data into respective data service to expose them.
Oh, I love that question. In my mind, it only works if the organization creates the incentive to share data. And if you share data and you don't want to consume any data, all the power to you. But the hardest problem is, how do you incentivize a team to share in the first place?
We've got a hand, hand up. Let's see here. Okay, we should be able to hear you.
Yes, thank you. Assuming that you hear me, thank you, Gregor. It was a really great presentation.
Thank you.
For me. Many questions, but to pick one, I wanted to understand the data services layer is where the data, the original data sources are already sort of transformed into graph data. Is that correct? Do I understand?
Yes. Well, data services, they live in Kubernetes, like containers. We can fire up as many as we want. And every application gets a container assigned. And they can choose what they want to expose. And they just map the data that they want to expose into the ontology and expose it that way.
Gotcha. So there isn't like you sort of bypass the, I mean, I want to say the more traditional, but I don't know if it's traditional. It's relatively new. The notion of having like a data lake or a data vault that is still kind of closer to the original schemas. You just turn them into graphs and make them available to convergence or integration later on. Is that, do I understand it right?
Yes. But as a thing, so we still have data lakes. You can pipe the data into, in our case, we're on Azure, so it's ADLS. So you can also pipe the data there. To be seen. It's one way, as long as, so we have this data, Kafka-based data distribution network. Where you pipe the data out is up to you, or it's up to the data producer and consumers where they want to have that data and how they want to consume it.
Thank you.
Thank you.
Very good. One other in the chat, just more of a comment. The organization needs to commit to data governance similar to the normalizing of a database.
Yes. Is that a question or just a statement?
Just more of a statement, it looked like.
100% agreed.
One other question that came through, was there a division or a particular business unit that embraced these things earlier or pushed harder for the transformation?
Yes, we have some business units, we call lines of business, that are more receptive because they have more pain or just are more, it comes to personality. Some lines of business have very forward-thinking development organizations, and they partner with us. So I work in group in the Chief Technology Office. We're building solutions for the entire firm. So we have some organizational groups that are partnering early on with us. It's just the sheer size of the organization just natural. Some are faster in adopting than others. It's just the nature of the game.
Yep. Okay, I think that, one more coming in. Do you have any certain recommendation when it comes to generically modeling the information graph? In particular, we're in the automotive aerospace industry.
I have no experience in the automotive or aerospace industry, but I would assume that you can leverage some. There must be a top-level ontology. Similar in our case, in the financial world, it's FIBO. I'm pretty sure there's some top-level ontology about the automotive or aerospace industry as a starting point. And the rest is, or the addition then becomes relatively simple. And worst case, if there's nothing available, you can even start with something like IST or any other top-level ontology that starts out with a party domain product. And it would be a good starting point. Again, my recommendation is start out with something that you get with an open standard.
And sorry, there was one more I missed earlier. Peter had asked, I think it was in relation to moving data out of the organization, if you utilize Swift My Standards related to ISO 20022 standards.
I'm not familiar with so Swift. We leveraging, obviously, as a financial institution, we're leveraging Swift.
Yep. Peter, I'm going to hand him the microphone. I think he can explain that a little bit better than I am speaking. Let's see here.
This is the same as FixML, then yes, we're mapping to it.
Peter, you're muted, but you should be on stage now.
Okay, can you hear me? Or
Yep.
Yes.
Yeah, good presentation, Gregor, by the way.
Thank you.
So I know this from being in Brussels, where Swift is headquartered. And my friend Mark Delbarra was responsible for this My Standards thing, which is money transfer formats. And that allows their members to contextualize their financial messages. But I found it interesting, and I think that kind of framework could be used in other industries. But I was just wondering if you had any comments on it. That's all. Thanks.
So we're using FixML. I'm not familiar with My Standards, but it's the Swift and money exchange schemas. We're mapping to it. So we're leveraging. So for us, it's data in motion, and we're mapping to those. For us, it's just another schema description, those messages.
Very good. I think that covers it. We ran over just a couple minutes, but Steve, I'll hand it back over to you.
Yeah. Thank you so much, Gregor. Just one follow-up question, just in regards to the direction, as to what the future holds. What's that roadmap look like? Just take one last minute and just perhaps provide what you see as an overview for where you're going to be going.
So what's on the radar in terms of where we want to bring it? We want to make this year really the year where the data mesh comes to life. So we have all the building blocks, and now we're slowly building it out. Really to see the organization embracing the idea of data as a product. We have a long way to go, but this will hopefully be the year where we make this a reality.